Hi guys, welcome to my channel. In this video, I am going to start the new subject which is ACD, and this subject is also the scoring subject, and few students get little confusion on this subject. I'll try to explain without any confusion in easy manner. Okay, don't miss any of the video in this ACD subject. Without any further delay, let's start the video. Yeah, the full form of ACD is Automata and Compiler Design. So A stands for Automata, C stands for Compiler, and D stands for Design. So in basic English, so what is Automata, what is a compiler, and what is a design? Okay, let's understand by each and every word. Okay, a machine that can run automatically by following a set of sequence of operations is nothing but the automata. So which it can run automatically. In the word only it suggests it's automata. Automatically it can run. Okay, with some set of operations. With some set of operations it can run it automatically. It can run automatically. To say more simply, if you have one machine, so which it can run the operations automatically, that is known as automata. Okay, now what is a compiler? You all know, a computer program that translates the source code written in a programming language into the machine code, means which converts the source code into the machine code. Yes or no? So that is known as compiler. What is a design? It's like a design. So altogether it is nothing but the ACD, automata, compiler, design. Okay, now let's see the introduction. So in theoretical computer science, automata theory is a study of abstract machines. So what is this abstract? Abstract is nothing but the mathematical machines, or simply we can say it's some systems or machines. It is nothing but the abstract machines and computational problems. So abstract machines and the computational problems. The study of this combination is nothing but the ACD. Okay, abstract machines, which is nothing but machines of the systems, and computational problems. Okay, that can be solved using these machines. So these problems can be solved by this abstract machines. Altogether is known as this abstract machines is nothing but automata. So what is this abstract machines? That is known as automata. Okay, don't worry. So when you go further, you can understand more clearly each and every word. Okay, because this all the words are new to you, so that you can get somewhat confusion at the starting point. When you go further, you can understand one by one. Yeah, now I'll explain you with the small example so that you can understand more clearly. Okay, now look at here. It has a mechanism to read the input. It will be reading the input file, so which consists of some set of or some strings of characters, some set of characters over a given alphabet, such as ASCII or Unicode character sets. The input is created on an input file. Okay, in this we'll be having some set of characters. Okay, next, which can be read by an automata but cannot change it. So if you take this input file, it will goes into the control unit. So what will be there in the control unit? We have some storage where this set of characters will be stored. Then output will get the result which will be stored in the output. Okay, now let's take the real-time example. Okay, you all know about the lift, how the lift will be operating or it will be working. So if you take the example of the lift, so what is the input thing will be doing after once we'll enter into the lift? We'll press the floor number, which floor we want to go. We'll be pressing that floor number. Yes or no? That is the input which we are doing. After entering the or after pressing the button of the floor, what the lift will be doing? It will be processing. It will be going into the particular floor which you have pressed. So it will be doing some operations in between. So after completion of that, it will be stopping at the floor which you have pressed. So that is the output. I think you got somewhat clarity. Input, some operations it will be doing in the internally, and the output will get the result. Okay, so this is the mechanism how the automata will be working. Okay, similarly you can take the example of vending machine. So what the vending machine will be doing? So we'll be inserting the coin, some operations will be performing internally, then we'll get the some product, output. Yes or no? Okay, similarly traffic signals, okay, bulb. So this all. So day to day life, these scenarios will be erased for each and every person. Okay, just relate this example to our subject so you can understand more clearly. Okay, so this is the thing: input, some operations which will be done outside, sorry, some operations will be done internally, then we'll get the output. Okay, now, yeah, these are the concepts which we are going to cover in this unit 1. Yeah, now let's understand what is the automata theory. So it is known as theory of computation. Before only I said it is a combination of automata and computation. So it is a theory of computation, which is nothing but TOC in short. Yeah, computation means processing input towards the output. Okay, input, some operations, output. Yeah, step by step solution to be to a problem. So we have some problem. So it will be done step by step. If you press the button of the left, so it will be done some operations. Then we'll get the floor which we have pressed. So some step by step operations will be done. Yeah. So here they gave some multiple two numbers, which is search word in a dictionary. So this is also this scenario only, and search city in a graph. Okay. Now for every device, there will be low level implementation, which we can say calculation, implementation or the calculation, low level implementation called abstract machine or model. For any device will be having some calculation or some low level implementation. Yes or no? So which we saw in this real time examples. So that is known as abstract machines. Okay. Now, so this is the example of switch. So we'll be having two buttons, which is sorry, we have on and off. These two operations will be having. If we'll on the switch, then the bulb will be on. Then if we off the switch, then the bulb will be off. So this is the diagrammatical representation, and this is the transition table. Don't worry of this thing. So when you go further, you can understand this thing. But as of now, take this example. Okay, in this way we have to representing in this automata. Okay, in this way we have to represent. Okay, so if you see here, this on state is nothing but Q1 and off state is nothing but Q0. So we'll take the two states, which is the off and on. If you press this button, then which is initially in the on state will be off state. If you press the off button, which is initially in the off state, will turn to on state. Okay, to see more simply, ఒక స్విచ్ బోర్డ్ ఉంది ఆర్ విచ్ కనెక్ట్స్ టు సమ్ ఫ్యాన్. సో అది ఆల్రెడీ ఆఫ్ స్టేజ్ లో ఉంది, మీరు ఫ్యాన్ వేయాలనుకున్నారు. సో దెన్ వాట్ యూ విల్ బి డూయింగ్, విచ్ ఇస్ ఇన్ ద ఆఫ్ స్టేట్, యూ విల్ బి టర్నింగ్ ఆన్ టు ఆన్ ద ఫ్యాన్. So already fan is on, you want to off the fan, then what you'll be doing, you'll be offing the on button. Yes or no? Which is already on లో ఉంది, మీరు ఆఫ్ చేయాలనుకుంటే అది ఆఫ్ చేస్తారు. Yes or no? So which you want to turn on, then on లో ఉన్నది ఆఫ్ చేస్తారు. Okay, I think you are relating this thing. Okay, don't get any confusion. Just as of now, take this thing as a reference example. When you go further, I will be explaining you more detailingly. Okay. Yeah, such machines which takes input and gives output, okay, is called abstract machines, or we can say model. So it is called as automata. So the whole scenario, which is nothing but the automata. So it is a low level implementation, or we can say calculation. Yeah, if these models or machines implement in finite number of states, so if these machines or these models will be implemented some finite number of states. If you see it here, we have two states, which is on state and off states. We have some finite number of states. So this is known as finite automata. Why? Because we are using some finite number of states over here. So this is one state and this is another state. So if we are using the finite number of states, it is known as finite automata. I think you got clarity. Yeah. So we see finite automata is a abstract model. So this finite automata, we can say this finite automata is nothing but the abstract model or abstract machine. Okay, yeah. A mathematical model which takes input, process, and gives output. Okay, automata theory is a study of abstract machines. Automata theory is also known as here only as it is a theory of computation. So it is a theoretical branch of computer science. It's a branch of computer science. This automata theory is a branch of computer science and mathematics, which deals with logic computation. So it's a combination of automata and compiler or computation. Okay, yeah. So which will be following some predefined sequence of operations. Okay, yeah. Automata with finite number of states is called finite automata or finite state machine. So these are the applications of automata theory: compiler design, pattern matching, spell checking, and can be used as model for learning and decision making and switching theory. And one more thing, and it is used in designing the part of compiler, which is the lexical analysis. So you all know what is the lexical analysis. Just see what is the lexical analysis. This phase reads the input source code character by character, grouping them into the meaningful unit called tokens. So if you see, this is the diagram of lexical analysis. Will be having some source code and which will be read by character and grouping them to the some meaningful units, which is known as tokens. So let it be, this is the source code while I greater than 0 and I is equals to I minus 2. So this is the source code. So it will be read character by character and it will be grouping them into some meaningful units. So this is the units. So which is nothing but the token. I think you know about this lexical analysis. So in this also this lexical analysis also, so it is used in this designing this part of lexical analysis, and again it is used in designing the digital circuits. So the first application is compiler design, which I said before. Only the first phase of compiler, which is compiler design, is lexical analysis. So that supplies the given sentence, or we can say source code, into the token check. So some units, okay, so that units are nothing but the tokens. So whether the tokens are, it can be the keywords, so identifier operations and punctuation symbols, etc. So yeah, we'll be using this thing in the automata theory. So and even it is used in the pattern matching. So used in like recognizing some patterns. Okay, it is used in some recognizing some patterns and spell checking, and it is even used in some models for learning and decision making. And switching theory means, like in this switching theory we'll be using some like designs of some digital circuits. So even it is used in designing the digital circuits, and it is again it is used in the scanning the large web pages. So we'll be having some large web pages, so to scan that the web pages also will be using this automata. And also it can be used in some text editors also. So these are some applications which will be using this automata. And I think you got some clarity of this automata and the finite automata. And that's it for this video. Thanks for watching. Let's meet in the next video with the central concepts of automata theory. So this is very important, so don't miss this video. Okay, thanks for watching. Let's meet in the next video.